Friends and guests. A very happy Diwali to all of you. Heavy rains in August created floods in low-lying areas in several parts of Kerala. That triggered a lot of calamity. In October, heavy rains triggered landslides, causing devastation and death. We know that our state has received 135% excessive rain this year, and the situation may repeat in future. Therefore, technology for flood protection through various methods has become vital. Today's speaker, Engineer Praveen, an inventor who has several innovations to his credit, will be sharing some light on his invention, and he will also, if time permits, say something about what he has in mind regarding a few other projects. On the eve of Deepavali, let us all strive to bring light to the lives of our fellow men who may not be as fortunate as us, and make life a little better for them. Now I would request our Vice President, Engineer Ratish, to formally introduce Vipin. Not Vipin, Praveen. Ratish, please.
Ratish sir, your mic is muted, sir.
Okay.
Yeah.
Is it audible now?
Yes, sir.
Ratish.
Okay. Thank you, sir. Respected President of the function, Engineer Anand Menon, President AEA, Chief Guest of the Day, Engineer Praveen Vettiyatil, CEO, YCA Technologies Private Limited, Secretary Engineer Thampi, Vice President Engineer Paul Joseph Katukaran, Treasurer Vibin Patnaphan, Joint Secretary Engineer Jagdeep, past presidents, executive committee members, and members of the association. Good evening. I have immense pleasure in introducing Chief Guest of the Day, Engineer Praveen Vettiyatil, CEO of YCA Technologies Private Limited. He is a serial inventor and a great motivational speaker. He has more than 20 years of experience in the industry and academia within the country and outside, including US. To transfer his inventive skills to the students and to motivate them to become inventors, he has created an online movement called You Can Invent in 2011 and has given You Can Invent talks in more than 100 engineering colleges, high schools, and innovation conferences within India and abroad. His invited talks have been given at Hanover Fair, TEDx Sharjah, TEDx NIT Calicut, TEDx NIT Surathkal, apart from various IITs and NITs in India. He was Director of Renewable Energy at Nurul Islam University, Tamil Nadu, before he founded YCA Technologies in 2018. He took his BTech degree in Mechanical Engineering from GEC. He holds a master's degree in Manufacturing Engineering and Entrepreneurship from University of South California. He is continuing his passion for innovation, and we can expect greater things from him in the coming years. With this brief introduction, let me invite Engineer Praveen Vettiyatil for his talk on expandable flood barriers, which is most relevant in our current context. Thank you. Thank you very much.
Thank you, Ratish sir. So next we will be listening to our guest of honor. Sir, please, Praveen sir.
Yes. Can you all hear me? Okay.
Yeah.
Okay. So let me start today's pleasant evening by wishing all of you a happy Diwali. And before I start my talk, I want to thank Engineer Anand Menon for giving me a chance to talk to very smart engineers and engineers from Thrissur underline. And also, I want to thank Engineer Ratish for the great introduction. So the story starts like this. In 2018, suddenly there is a big flood and a lot of my relatives who live on river banks, their houses get flooded indoors. And when I go to help them clean the indoors, I see close to 6 inches of mud and decayed fishes, a lot of stink inside their houses. And a lot of us relatives pulled in some money to help them refurnish and refurbish their indoors. So I decide myself that there has to be a solution for this. And it has to be a smooth and convenient solution. So I Google and I find a lot of fixed design flood barriers made of steel. So a contractor will come to you and take the exact measurements of your door and door frame, and then go back to his factory, make a steel-based flood barrier which is of a fixed design, and then fix it onto your door and door frame. But this involves a lot of holes and permanent constructions on your door frame and on your walls and on the building. And even if the steel fixed design flood barrier is 1 millimeter more or 2 millimeters less, it will not fit in door or it will leak. So I decide myself that it has to be an expandable flood barrier, so that there are no permanent fixtures on your building. Once you remove it, nobody knows that something like this has been fixed. So it will not affect your aesthetics. For the next few minutes, I'm going to show you some videos of my product. But before I show you videos of my product, I also want to show you some reasons why I believe Thrissur is the innovation capital of Kerala, and maybe Thrissur is the innovation capital of India. So let me quickly share my screen. Okay. Can you all see my screen now?
Yes, sir.
Okay. So hold on. I want to start with a little bit of history. Okay, this is just about 5 minutes of data. How many of you know? Again, I'm mentioning this because the audience is from Thrissur, so I wanted to know the real power of Thrissur. How many of you know that Aryabhatta, the famous Indian mathematician come astronomer, is actually from Kodungalur? And look at his amazing achievements by the 5th century. He explained the lunar and the solar, explained the rotation of Earth on its axis. He used sinusoidal sine theta and cos theta to solve mathematical problems. He developed a solution for quadratic equations. He calculated the value of pi for 4 decimal places. He calculated the diameter of Earth. And he also calculated the exact length of an year to be 365 days. And this is Madhava Nambudri. He has his origins from Kalletunkara, close to Iridalakoda. It's a proper Thrissur area. And I discovered this fact while reading a book in 1998 at the library of University of Southern California. I was looking for different ways to calculate pi, and there is a book called Pi, a source book, which has all the methods to calculate pi. And the first mentioned pi with high accuracy, with 11 digits of accuracy, was about Madhava Nambudri. So the sad thing about our education system is that I should have learned this here in Thrissur, but I came to know about this when I was doing my master's degree in Los Angeles. And you look at He lived in the 13th and the 14th century, and he created the equation for trigonometric expansions of sine A plus B. Expansion of trigonometric functions. He discovered summation of infinite series, which is a base for calculus. He calculated the value of pi to 11 decimal places. He established a school of mathematics and astronomy in today's Tirur in Malappuram, which again created dozens of mathematicians who were born and brought up in Thrissur, Malappuram area. Now, not just this. Recently, I was studying about, I do a lot of reading on history, and I was curious to know the major maritime silk routes in the world. And I discovered between 45 and 50 major maritime silk routes. These maritime silk routes were the major seaports which existed 2000 BC to 1400 AD. And it is through these maritime silk routes, great ideas and people and goods traveled around the world. And out of close to 50 maritime silk routes, close to 13, actually 13 are in today's India. And so I was curious to see which two ports were the closest. So I tracked down every one of these ports, and I found out that the closest to maritime silk routes were Cochin and Kozhikode. Now, this map is not drawn to scale. This is Cochin, this is Kozhikode. The next is Mangalore. Then you have Goa, then Mumbai and Surat. So the gap between Mumbai and Surat is close to 300 kilometers. And these two maritime silk route stops in Sri Lanka is actually the port of Trincomalee and the port of Colombo, which is 270 kilometers apart. The closest two silk routes, and this is again the port of Thoothukudi and the port of Chennai, which is again 500 kilometers apart. So I discovered that the two closest ports of silk routes in the world was actually Cochin and Kozhikode, a gap of 190 kilometers. So it was a pleasant surprise for me to discover that that would mean that Thrissur Malappuram area was the only place in the world which had two maritime silk routes within a gap, within a distance of 100 kilometers. So that also tells you the amount of wealth in Kerala, the amount of wealth in this Thrissur, Palakkad, Malappuram region, which had two maritime silk routes. And remember, there are only less than 50 such stops, such ports in the whole world. And there were only 4 ports in China. And these ports had a distance of average of more than 1,000 kilometers apart. So I want you to know, and I want you to tell this information to all your friends and relatives. We know the performance of Government Engineering College. I used to read in the newspaper that the students from my college, my former graduating college, they are winning national and international prizes on innovation. I don't see this much prizes won by any other college. Maybe there is another one or two. You all know that NIT, Calicut and Trivandrum Engineering College have a lot more facilities, a lot more money. But I don't see enough innovative projects getting national, state level awards and even international awards, as I see from the Government Engineering College should. So with this, let me go on to, so please share this information to your friends and family and children and grandchildren that we have a great past. So if you look at the mathematical equations I showed you in the past 2 slides, they actually form about half of mathematical equations we learned during our 10+2 or during our 12th grade. So that means that about half of mathematics we learned in our high school was actually created in Thrissur and in Malappuram area. So with this, let me close my PowerPoint and let me show you. So I'm beginning to explain my flood barrier by showing you an existing flood barrier. So I think I will have to go to YouTube again. Hold on. Okay. So the video which is going to play right now is an existing flood barrier made by an American company. Okay. So this is the flood barrier. It has a height of 65 centimeters, and on the front side you have this rubber, and it will prevent flood waters from entering your house. Now, the video also shows you the back side of this flood barrier. So I want you to take a look at the back side. This is the front side, the orange of the flood barrier. Now, this is the back side of this American-made flood barrier. So what you see is a screw jack, the device used in our cars to lift the car to replace tires. So this is a screw jack, and if you rotate the screw jack here, the screw jack will expand, and when the screw jack expands, the frame, these black pipes, the frame will expand, and the frame is covered by this rubber cover, and the rubber cover will expand. So this is the simple principle used by an existing manufacturer. Now, I want to show you some defects of this design. The defects of this design are: first defect is that you can see sewed joints on four corners. On four corners, you can see sewed joints. So what this company has done, to my knowledge, is to take a rubber sheet, fold it on four sides, and then join the four sides by sewing or by welding. I want you to know that rubber joints are not strong when they are welded. They are not strong enough as a single piece. And sewed joints have the risk of being torn. And once these joints break, the flood barrier fails. So to reduce the risk of the joints being torn when the flood barrier expands, the company has sewed the entire border. You can see this black line. It's the entire border of the flood barrier is sewed. So this means it is labor intensive. And now let me quickly play this for 2 minutes. You can see the operation. Once, yeah. So you keep the flood barrier on your front door frame, and then you rotate the screw jack, and you can see the expansion. Once it's expanded, then you tighten the bolt at the bottom, and it will tighten towards the bottom direction. So this is how an existing model works. And let me show you the performance of my model. But before that, let me show you a close-up of the backside of this flood barrier. So this is a close-up of the flood barrier, and you can see. Let me close. I want to show you a bigger picture. Open with. So if I expand this little bit, you can see the sewed joint right now. I'm thinking all of you can see the sewed joint, and you can also see a double line sewing even the color of the thread can be seen as white. So there is a double line seam joint throughout the border of this rubber. That is one of the weak points. So close this down, and now let me show you my product. Now this is the expandable flat barrier which I designed, and I also decided that because the water level during floods in Kerala is higher than the average that you see in US, I decided to build one for the height of 2.5 feet. I want you to know that the height of the previous flood barrier is only 65 centimeters. And I called them up and I requested them to see if they can supply me a flood barrier with the height of 75 centimeters. And they told me that 75 centimeters is too risky. It simply cannot withstand the hydraulic load. And they told me that 250 to 300 kilograms would be the hydraulic load. They told me that their frame cannot withstand the force. So this is the reason I decided to make this 2.5 feet high or 75 centimeter high flood barrier. So let me quickly show you. What you see is the outer cover of the flood barrier, the rubber cover, and the video you can see me operating an expansion system, and you can see the flood barrier expand in the horizontal direction. So let me close this. Let me show you the video. Okay, so this is a video. This video is actually available online. It's on YouTube. If you search for flood barrier, this product will be on the first page. So it's obvious that nobody else is making this in India. Now, if you look closely, you can see a 1-inch gap on both sides of the flood barrier. So the flood barrier is designed to be slightly less than the normal size of a door. And you can see that there is a 1-inch gap on both the sides. And I have designed a proprietary mechanism and a proprietary steel frame. So the difference between my product and the product made by the American company is that the frame is different, the expansion system is different, and the rubber design is different. Now, in this presentation, I will show you some details about the rubber, but I hope I can show you the expansion system and the frame when I launch it, hopefully by the rainy season of 2022. So in this video, as the video continues, you can see that I'm operating the expansion system, and you can see the gap between the rubber and the wood reduces. And you can see I'm only taking about 30 to 40 seconds to achieve this. And now the rubber has almost tightened. And you can see after a few seconds, I'm standing up and I'm applying a lot of force on this, but the rubber doesn't move. So you see, I'm applying all my force, but it remains still. Now I will quickly show you. I will quickly fast forward to give you a demonstration of this. So this is the steel tank I'm using. It's a steel tank made of a 2 millimeter thickness steel sheet. It's bent by CNC bending. It's cut by CNC laser. This is why I go to Coimbatore, because they do it immediately. People in Thrissur make me wait for a week. So So in this tank, you can see the top side is open and the front side is open. And the front side I will close by using the flood barrier. So this is the wooden part. This is supposed to be the door frame. I'm trying to make it as realistic as possible. So once I keep it on this open tank, I will expand as usual. But when I expand, I want you to know that the steel tank is not as strong as the wooden frame on your door, because the wooden frame is reinforced by strong concrete brick walls on both sides. They can withstand more than a ton of expansion. Here, the expansion force is only about 300 kilograms, but the steel tank cannot expand that expansion force. So if I expand the flood barrier, the steel tank also will expand. So to make sure that the steel tank does not expand, I have fixed a steel frame around the steel tank, and I have expanded the flood barrier to tighten and closing that constraint. Now I will fill this tank full of water, and you can see that I will show you it's being filled with water, and you can see now the tank is full of water. The height of the tank is 780 millimeter or 78 centimeters, and the water is 2.5 centimeters below. So the height of water is actually 75 centimeter plus. It's close to 75. Why have not I filled the entire tank full of water? Because if I fill the entire tank full of water, if anybody touches the surface, the water will spill over, and then I cannot show you that there is no leak from this tank. So that is why I have kept close to a 1 inch gap here, and you can see that it's a 2.5 feet, and the front side is covered by this flood barrier. And the front side of my flood barrier I have concealed with a steel sheet. And you can see the surface. I'm touching the surface, and it has a height of, you can see the steel tank has a height of, this is 70 centimeters, and this is 77.5 centimeters. So it's clearly a 75 centimeter high water level demonstration. And so this is, so I tried this for 2 days, and for 2 days there was not the flood barrier stood steady, and there was no leak. And even now you can see there is no leak. You can see the floor is dry. So let me close this video, and let me tell you that okay, if I close here, it goes off. And let me tell you that anybody who wants to see a full video, they can go to YouTube. I'm also willing to give a live demonstration to the members, the executive committee members of AEA after 2 weeks, because these 2 weeks I'm busy going to Coimbatore and making a stronger model. But anybody who wants to see a 7-minute video of my demonstration can search flood barrier on YouTube, and you can see that this flood barrier will come on the first page. So this is my video. These two appears to be paid advertisements because they are not based out of companies. So let me close this, and let me open. Let me show you some more details. Okay, so now I have shown you the features of my flood barrier, and so I went to Google. I called this company up and I said, I want to buy two of your flood barriers for my house in Kerala, and they are aware of the Kerala flood. And they told me that the price of one of this, which is only 65 centimeter high. Remember, my product is a whole 10 centimeters higher than their product. And they told me that the price of one is 160,000 rupees plus 3 months of wait plus transportation. So I was so surprised by such a high price from their side. And so I went to Amazon and I found out that for Amazon India, the price is close to 2 lakhs. This is for one piece, remember. So if you are to buy, if you are to buy two pieces for your front door and the back door, a house has at least two doors. You would be spending 4 lakh plus cost of transportation and 3 months of wait. So I told him I will buy this. I will buy two pieces and I will wait 3 months. And they told me that they are not supplying India because of demand from other countries. I don't know the exact reason why they are not supplying India, but they told me they are not supplying India. So these are the reasons. Even called them 2 or 3 months back when there was that big flood in China, and they told me their factory is overbooked because of flood in Europe and China, so they are not supplying India. So I called them twice. Both the time they told me, and they are suggesting that I use sandbags. Now to use sandbags, I don't need the advice of these people. So this is the market environment for which I try to solve and create a solution. And finally, I'm lucky to see that my product is able to withstand water pressure of a height of 2.0 feet or 75 centimeters. And I created artificial waves. It is still withstand. But my plan is to raise funds and launch this product by the coming by 2002 winter season. Before that, so I designed a demonstration. This is my demonstration which I have designed, and I hope to build and demonstrate to investors within the next 4 to 6 weeks. So this is a 3 meter by 3 meter room, and you have seen you are able to see the flood barrier fixed on the front door. You can also fix the flood barrier on your window sill. You can fix it on the indoor side or the outdoor side of your window sill, and I will build this. I will build this brick wall water tank, and I will fix a wave generator and create waves, as you can see in this animation. And now the investors are sure beyond any doubt that water will not pass through the flood barrier. The investors can enter through this door. And they are also sure beyond any doubt that water will not enter through brick walls. Right now, a question remains unanswered, and that question is, what if water enters through brick walls? And my friends who are civil engineers tell me that very small amount of water will pass through brick walls. But I'm a person who don't believe in talking a lot. My speech is my action, and therefore I have decided to build this demonstration so that I don't have to. You probably know by this stage that investors, as a negotiating strategy, will try to exaggerate any possible weakness of my flood barrier, even if the weakness doesn't exist. So this is, let me close this. And all the water which could enter into your house through drainage pipes, you can fix a ball valve. And whenever there is flood, you can go outdoors, close the ball valve. And you can also fix a ball valve on your septic tank outlet. So this is a 4-inch pipe. This is a 4-inch pipe septic tank outlet, and you can fix a ball valve. And whenever the water level starts rising, you can go outdoor and close the ball valves. So this is how you can prevent flood from entering your houses. So let me close this video and let me. Okay, so as after this, I want to mention some market potential size of flood control. According to United Nations publications, 2 billion plus, 200 crore plus people live in flood-prone area, and this is data published in 2017. Now, because of global warming or climate change and from the rain that we see around us, in Henan, they say that this year was the biggest flood in 100 years. In Europe, they say that this year was the biggest flood in memory. So, and even in Kerala, I'm surprised to see that there is 2 hours of continuous rain in November. And even today, there is orange alert in 5 or 6 districts in Kerala. So, the market potential is more than 2 billion people. Now, I want you to know that the world population is about 8 billion people, and 2 billion people form about 25% of the world population. Now, assuming 5 people in one house, which I think is more than reality. In many countries, it is 3 to 4 people per house. But assuming 5 people per house, 2 billion divided by 5 will be 400 million. So there are 400 million houses plus non-residential buildings. So I'm neglecting the non-residential buildings because they are a small percentage of the residential buildings. 400 million houses wanting 2 flood barriers at least. So the potential, the global potential is more than 800 million expandable flood barriers. And if flood barriers can be produced for much lower price, remember the price of the American company is 4 lakh plus per house. My product, if I can make 100 pieces per day, I can easily sell for 25 to 30,000 rupees per piece. So it's only 50,000 rupees, 50 to 60,000 rupees per house, compared to 4 lakh plus per house for the foreign model. And the foreign model is 4 inches lower than my product. And the other thing is that my product can expand to can expand by 1 feet, by 1 foot. The foreign model I showed you, because they have 4 joints and they are sewing all the joints, there is a risk of breaking or shearing if you expand more than 6 inches. But my model can expand to a length of 1 foot, which I experimented in Coimbatore about 2 weeks back. So, you know, because this is a demonstration, let me make a full screen. Just hold on. Okay, so I will quickly show you the rubber cover because it's from Thrissur. You know, all of you are my friends or my seniors or my relatives, so I will show you the rubber cover. I will not show you my rubber. If it were some other talk. So hold on. So this is the back side. Is my sound clear without the? Is my sound clear?
Yes.
Okay. So this is the back side of my rubber cover, which you saw in the video. And let me show you the front side.
Sir, actually,
This is the.
Excuse me, sir. Praveen, sir,
Is my sound clear?
the sound is clear, sir, but your display is actually your monitor right now, screen right now.
Oh yes. So you cannot see my display, right? Okay. So in that case, I will stop sharing.
We could see Vipin.
Okay. So can you see my face now?
Yes, yes, yes.
Yes.
Okay. So I will show you the display again. This is the back side of my flood barrier. As you can see, this is a single piece made by molding. And you can see it's a perfect 90 degrees. It is not a bent and sewed joint. And if you look at the front side, now if you look at the front side, you can see the corner is a perfect 90 degrees, and there is no sewing here. There is no sewing around the edges, and there is no sharp corner here. It's a smooth bend. So there is absolutely no chance of tearing here. And this is why my product, I believe, is much superior and can expand to an additional length of 1 feet. So this has a 3 feet length now. But if your door frame is 4 feet wide, you can use this for 3.5 feet wide or 4 feet wide. But if you buy the American model, you can only use it for 3.5 feet wide. And for a 4 feet wide, you will have to buy a bigger model, which can cost you maybe 2.5 lakhs per piece. Okay, so let me come back. Let me fix my my headphone. Just hold on. Okay, I'm back with my headphone. Is my sound clear?
Yes.
Okay, great. So that is, so after I posted the video on YouTube, I got more than 500 people calling me from around the world through Facebook, through phone. And now I become an expert on flood prone areas, the world. And let me also give you a primer on floods. Some of you are wondering why suddenly so much floods. To tell you why, I have to tell you that there are 3 kinds of floods. Basically 3 kinds of floods. One is called the riverine floods. Most of the flood we have in Kerala is the riverine flood. So water falls on the mountains and it floods the river and the river overflows. A second kind of flood is called the storm flood. So in storm flood happens in beaches. And this happens in Florida, in US, it happens in Japan, it happens in the Philippines. It happens in places which has a big coastal line. It happens in Calcutta, West Bengal. It happens in Chennai. It happens in Visakhapatnam. It happens in Mumbai. The last tortoise cyclone actually went parallel to the coast. So all the coastal regions are vulnerable to storm flood. Storm flood happens because of cyclone, and then the water level of sea rises, and the waves are violent. They have a good speed, and the speed gets converted into higher level of water. They get indoors, they come into land. A third kind of flood is called the flash flood. So flash flood happens when there is high intensity rain, when there is a sudden high intensity rain. And for flash floods, there is no need for storm, there is no need for rivers. It can happen in any part of India. So I was surprised to get a lot of calls from Bangalore and Hyderabad. Hyderabad is landlocked, but they sometimes get flash floods. And water naturally flows to the lowest part of the city, and that part gets flooded. A lot of cities, one example is Firozabad in Uttar Pradesh. The altitude of land in Firozabad and many parts in Assam and Bihar and Uttar Pradesh and Bangalore and Chennai. In Chennai, there is a place called Boro. which has thousands of residents, and they fill the lake and they build buildings and houses. So whenever there is rain in any other part of the city, water immediately flows to the lowest level, and it floods 3 to 4 times a year. It's not just once a year. So some of you are thinking that Kerala floods happens only once in 10 years. So is there really a need for a flood barrier? The answer is yes, because even in Kerala we have Uttanad which floods every year. And in many parts of India, even in Bangalore, because all the big metropolitan cities are actually expanding, and they are in expanding concrete. The entire ground of the city is a concrete, so there is no space for what. There is no provision for water to go under the ground, and the drainages only form less than 1% of the total city area. So it's not logical to expect the drainage to drain out all the water from the rain. According to city administration of Mumbai can only withstand 1 inch of rain in 1 hour. 1 inch of rain. So they got more than 1 inch of rain 3 or 4 times this year, and it flooded in Mumbai 3 or 4 times this year. And this is true even for New York. There is no city in the world. Some of you think that if you improve the drainage, it will solve the problem. It will not solve the problem, because cities are already built and drainage has been built, and drainage only form less than 1% of the total area of the city. You cannot expect rain falling on 99 square meter to be drained by 1 square meter in a few hours. It will take a lot of time for the drainage to actually drain. The drainage works, but it takes time. It only takes half an hour of flooding for water to enter your houses and buildings. So this is the end of my talk on flood barrier. If you would like me to continue, show you another invention, which is a 100-watt technology to cool your bedrooms, I'm willing to do that. Otherwise, I could come back at some other time. And I want you to know that there are 7 inventions. There are 7 inventions in prototype form in my house, and 2 inventions have the potential to save more than 1% of global CO2 emissions. One is in transportation, one is in residential indoor cooling, and another is in lighting. I can, if there is a advanced level of interest, I could show one more technology which I call as night cooler, and I have implemented this in my house. I'm sleeping with this product called night cooler, which works on 100 watts. It sucks air. It sucks the cold air from outside during summer nights, filters all the dust, and blows straight onto my bed. So I'm sitting comfortably with cold air without the use of an AC. And I decided to work on the night cooling technology. Once I went to an air conditioning conference, and I heard a vice president say that the Indian air conditioning buyers are the most cost conscious. They are so cost conscious that 90% of residential air conditioner owners in India, they switch on AC only during summer nights. So they switch on AC from March first week, and then they switch on, and then they use it only during night until the first week of June. If you take the example of Kerala, once it starts raining, once it's cold enough to sleep without an AC, they switch it off, and then they on their AC during the next first week of March.
Praveen.
Yes.
One sec, Praveen.
Yeah.
A lot of questions for your previous invention, but
yeah,
then this one, I think, Praveen, you can briefly tell about this also. Very briefly. So because this is a matter which is of great interest to many people.
Yes.
So briefly mention.
President. Yes,
Yeah.
President, we have some clarifications on these flood barriers.
Yeah.
We
So
have-
just
yes.
let him
Yeah.
2 minutes in this and then you'll come back.
Yes.
Yeah, so I will quickly show my night cooler, for which I will have to share the screen again. I'm not going to go into details. Share. Okay, this is how the night cooler works. There is an outdoor unit and there is an indoor unit, and air is sucked in from the outdoor, and there is a two-stage filtration inside. All the dust and pollen is filtered, and air is pumped in. And this is the indoor side of, and this is the indoor unit, and behind this is the air hole, and behind this is this unit. So I will show you how I use this in my bedroom. So this is how it works in my bedroom. This is the indoor unit, and as you can see, the air flows straight onto the person. So this is my friend sleeping. The air flows straight onto your body, so you get 3 to 10 degrees of colder air, fresh air, filtered air, just for 100 watts of power consumption. So my parents use an AC. They spend 3,000 rupees a month or 4,000 rupees a month, and I spend close to 150 rupees a month because I only consume 100 watts. And I use a blanket within half an hour. I switch on this. And this is in March, April, May. It's because the air outdoor is 2 to 6 degrees colder than the air inside your bedroom. And at 80% humidity, 2 degree lowering of temperature will feel like 10 degree lowering of temperature. I'm not showing you the heat index. It's called apparent temperature, and the US National Weather Forecast has a heat index calculator. I will show you that after I take the Q&A, if there is time. So I'm closing my presentation on night cooler. Let me close this, and I think I will stop sharing the screen. Okay, am I back? Okay.
Thank you. Thank you,
Yeah.
Praveen sir.
Yeah, so if you have questions, please ask me. And let me tell you, all those who viewed are welcome to come and see. I was waiting for the corona to go away. Maybe after 2 months, after 2 weeks or 3 weeks, we can fix a date. I can give you a live demonstration, and you can actually create waves on the water and load it yourself and see it yourself.
Thank you, Praveen. Your offer is accepted. After 2-3 weeks, we will come there now because I've already told you a lot of people are interested. I think we can go for the question answers.
Yes. Thank you, engineer. Thank you, engineer. Shall I ask, President?
Yes, sir.
Please.
Please go ahead.
Thank you, engineer Praveen Vettiattil, for your very interesting and innovative research ideas. The very information that Aryabhatta is from our Kodungalur is very thrilling. Now coming to your flood barriers, can you explain a little bit about the modus operandi of fixing it? Because in buildings, doors are not the only openings. We have the windows, we have the arches, we have the ventilators, we have the air spaces, etc. Whether it is required for that also, and also the cost benefit aspects of fixing these barriers in our highly flood prone areas like Kuttanad? Is it practically we can use it with the cost benefit aspects, these flood barriers? Please enlighten us.
Yes, the answer is yes. The flood barriers I designed can close any rectangular opening. So people may ask me, what if the one side is 0.1 degree inclined? Well, the thickness of the rubber is 7 millimeters. So small defects in construction can be accommodated by my flood barrier. And right now, my flood barrier can withstand a load of 400 kilograms. The normal load of a 2.5 feet high water level, the static load is 250 kilograms of force, which is the weight of, if you weigh 50 kilograms, it's the weight of 5 people like you. So that is a horizontal load on the flood barrier. And the wave load can come up to 30 kilograms of force. So 250 plus 30, 280 kilograms of force. And my flood barrier can now withstand 400 kilograms of force. The reason I'm building a stronger one, which can withstand 600 kilograms of force, is because when I show it to investors, they will ask 2 members of their team to push the flood barrier with all their strength. And so it will come close to 400 kilograms and my flood barrier may start malfunctioning. So what I want you to know is that when I create this 600 kilogram strong flood barrier within a month's time, this is why I go to Coimbatore very often. It will have a factor of safety of close to 2.5. And I want you to know that even if there is an overloading of the flood barrier because of a coconut tree floating and impacting the flood barrier, even if that happens, that is a 1 in a trillion possibility. But even if that happens, exactly behind the flood barrier is your front door, and your front door can withstand close to a ton of force. So it will require 600 plus a ton, 1,600 kilograms of force to actually fail the flood barrier and allows a significant amount of water to enter your house. Now, to the exact question whether this has been tested in a real flood environment, the answer is no. But I want you to know that the hydraulic pressure is very much predeterminable, and I called up agencies which certify flood barriers in Europe and US, and what they told me is that they do not, before they certify a flood barrier, they do not test in real flood environments. They are asking me to supply a steel tank, and they will close the steel tank, like I said, and then they will fill water to a height of 2.5 feet, which I did, and then they will create 3 waves and 3 currents. Waves will have a height of 2 inches and currents will have a height of 6 inches. If any flood barrier can withstand 3 waves and 3 currents, it is certified as good quality flood barrier.
Yes, Praveen.
Yes, but
when the whole building is flooding, just like in Kuttanad recently happened, when the whole building is under flood, what is the use of protecting the door?
Yeah, it's a good question, but based on my measurements, I did some measurements in many parts of Thrissur where water got flooded, and I discovered that 95% plus houses were flooded, which were flooded had less than 2.5 feet of water. So I cannot guarantee a house which has water on 2 floors. I'm not supplying a solution to that. In future, I will do R&D, and it also depends on the strength of your walls. If your walls are made of mud, then with just 2 feet, 3 feet of water, it will collapse. If you have a very good quality concrete, and if your room is not so big, if your walls are like 50 meter by, say 25 meter by 25 meter, the walls may collapse because of hydraulic pressure. But most of the houses have rooms which are like 5 meter by 5 meter. In such cases, based on my calculations, flood level up to 5 feet can be protected by such flood barriers. I cannot guarantee water levels to a height of second floor, in which case, when water goes to a height of 2 floors, then you have a tsunami effect sometimes. So the whole water can flow, but if you look at TV news, you only saw 3 or 4 houses flowing, and the entire house is being uprooted out of thousands of houses which flooded. So the example you mentioned is a very small case, and I will, I'm not providing a solution for
Yes,
such.
thanks, Praveen. I think Ramakrishna Menon is satisfied. If he wants more clarification, I'll bring him when I come to your
Yes,
demonstration. There are others who want to ask.
Yes, we will do then. We will do at that time.
Yes. There are others who want to ask.
Okay, please go ahead.
Anyone else who wants to ask?
Yes, sir. Is it filled with air, that material? What is the material?
I'm using, there are 3 components in my technology. One is the rubber covering outside, and outside the rubber cover, inside the rubber covering is a unique steel frame I designed. So the steel frame I use is not the steel frame which you saw in the video. And my steel frame is a world's first, and this is why I put the term world's first on the YouTube video. I'm not able to see a 2.5 feet high, tall, 2.5 feet high expandable flood barrier in Alibaba or Google or YouTube or Amazon or eBay or Yahoo. I even call many consultants in Europe, and they all tell me that very few companies, I only know 1 or 2 companies in the US who make, to my knowledge, there are people making it to a height of 60-65 centimeters, but not 75 centimeters. Why I do for 75 centimeters? So I can tell my buyers that the window height in my house is 2.5 feet. And in Kerala, many houses have 2.5 feet window height because of the 99 flood. In 99 flood in the Malayalam year, I think in English year it may be 1921 or 22 or 23, somewhere there. In the 99 flood, more than 6,000 people died in Kerala. And my grandmother's homestead was built 1 year after the 99 flood. So they have a very high floor. The height of the floor is 6 feet. And because of one of the reasons why many houses in Kerala have 2.5 feet window is because of the 99 flood. So the window in my house and the windows of all the residents in my lane have a height of 0.5 feet. So I can tell the buyers that my product can prevent flood from entering your house up to a height of 2.5 feet. Now, if water goes beyond 2.5 feet, then people will have to spend much more money to buy a higher flood barrier. Of course, they can fix another one on the window, but many houses have 6, 7, 10 windows. So they may not be able to afford, but every house can afford 2 flood barriers. If you can spend 5 lakhs, if you can spend 25 lakhs on your house, you can spend 50,000 to prevent flood from.
Okay, thank you. What about the punching shear and shear resistance? Suppose some sharp things are coming and punching.
Yeah, so let me tell you, previously I tried a 3 millimeter thickness rubber, and I discovered that it works, but I increased the thickness to 7 millimeters to reduce the risk of shearing. And the other thing is that exactly behind the rubber there is a steel sheet. So first the rubber, so water comes, and then there is rubber, then there is a steel sheet. The steel sheet will support the rubber throughout the rubber area. After the steel sheet, there is the frame. So the rubber is supported throughout its area by a strong steel sheet. So the chance of shearing is very small unless somebody brings in a knife. Even if you shear, you still will not make a through hole. You will tear the rubber, water will have to enter through that rubber, go down, go around the steel sheet. Yes, if somebody tears it, water will enter, but normally it will not enter. But if somebody needs more protection, I am willing to provide bigger thickness rubber cover for those who are willing to pay more.
Thank you. Thank you very much. Thank you.
Thank you, sir.
One small
Yeah,
question.
Jaydas sir. Jaydas sir.
Yeah, that's it. Yeah.
To fix this barrier in one door, what will be the time frame required? How much time will be required?
Well, for a non-experienced person, it can take 5 to 10 minutes. For a person like me who is experienced, who has done this more than 50 times, I experimented this water loading more than 50 times. It will take only 5 minutes.
Okay.
Okay, thank you, sir. Any other questions?
Yeah, I have one.
Okay, Jagdeep sir, please.
Please tell me your name and which place you live. So,
Yeah, I'm Jagdeep. I'm Jagdeep from Purkanjeri, Thrissur itself.
very good.
See, what about those houses? You know, normally we have houses with large French windows. I mean, about 2 to 3 meters wide. So normally that comes with houses now. So what about that?
Yeah, there are a small number of windows which are made of glass. They don't have a
Yeah,
steel. But still, to my knowledge, there is a sill. There is a window sill area, at least on one side. And if there is no window sill area, if your glass is in line with the wall, then I have to think of a way to help people like you. Right now, my product cannot fit into that. But let me tell you, I'm 48 years old right now, and I visited hundreds of houses in different parts of India. And these windows, which are made of glass from the floor up, are I've only seen two or houses out of thousands. So I hope I hope I answer your question.
Yeah, of course, yes. But so till now you have no supply for that. I mean, you still have to think about it.
Yes, if there is a sill area between the glass and the wall, if there is a 2 inch of sill area, my product can be fixed on that and saved, and the windows can be saved. But if the windows are in line with the wall surface, then there is nothing to fit my expandable flat barrier onto, unless there is a sill area in the indoor side of the wall. But then it has to be made sure that the gap between the flat barrier and the glass is full of water. Otherwise, the outer pressure will break your glass. Or the expandable flat barrier must be in touch contact with the windows to make sure that the glass is provided enough support. And I invite you to come to my house to see my product.
Praveen, he is coming with
Sure,
me.
it's a pleasure.
Yeah.
Yeah, sure, it's a pleasure. Thank you.
Any
Anyone
other
else?
questions?
Any other questions? Oh,
I think we take it forward.
okay, sir. Okay, sir. Praveen sir, we would love to listen to you in person in our AEA hall. So let's move on to the next item, that is the pleasantries. I request our President, Engineer Anand Menon, to present a memento to our guests online.
On behalf of AEA, we have great pleasure in handing over a small memento as a token of our love and affection and the brilliant talk you gave. We want more engineers like you to, bring out innovative products. Thank you very much, Praveen. Please accept this. It will come to your home in 2 days.
Yeah. Thank you very much. And I'm very proud of. It's my time to talk, right?
Yeah.
Yes, sir. Yes.
Yes, I am very proud of and I'm quite happy to be in Thrissur. I have lived in the Bay Area in California. I have lived in Los Angeles and Dubai and Qatar and Tamil Nadu and Goa and Bangalore. Let me tell you, and Ernakulam also, and some more places. But let me tell you that I strongly believe that a great invention or a great idea which will solve the world's problems will come from Thrissur in the next 5 years. And great investors will also come forward from Thrissur. Some of you think that all the great ideas can be funded only by Europeans and Americans. It is not right. If you look at the history of Google, the first person who put in $100,000 into Google was an Indian professor, Rajiv Motwani. It was not an American person or a German person. So we should not rule out the power of Thrissur. And in real terms, I still consider Thrissur to be the richest place or one of the richest places on earth. Culture, and we are a very peaceful city. And I always promote Thrissur. Whenever I go for talks, I buy 5 kilograms of cold alwa and I buy 5 kilograms of Nandraparam. And if it is Priyur season, I buy 5 kilograms of Priyur and take it to college principals. And I don't know if you are aware from history that after Mysore conquered Malabar and Thrissur, Mysore became the world's richest country. They became richer than England. And this is between 1750 and 1799. And another thing is that when Tipu Sultan came and stayed in Thrissur for 4 months during the Battle of Nedumkota, it is a Priyur season. It is the jackfruit of Thrissur season. He stayed in Thrissur for 3 or 4 months. And he was so impressed with Thrissur that he decided and he announced that the capital of Malabar will be shifted from Kozhikode to Thrissur. So this is the power of Thrissur.
Thank you so much.
We hope that happens soon. And we move on to the vote of thanks. I request our Secretary, Engineer Thampi, to propose the vote of thanks. Thampi sir, please.
Okay. Thank you. I take this opportunity to thank Engineer Praveen Vettiyatil, inventor, entrepreneur, for his enlightening presentation on expandable flood barriers, a very relevant topic in flood-prone Kerala scenario. Thank you very much, sir. My sincere thanks to each and everyone who actively took part in this webinar. Thank you all.
Before we close, I would like to tell all the viewers that Praveen's transportation model, which we spoke about for some time, is mind-boggling. I don't know how practical we can make it, but if you listen to him, then you can keep on listening. We'll have another. I think we should have a once Corona comes down, and people like VRU and myself are more, and Achutamanan and others have more guts to go out freely. I think we'll have a physical session with you. It will be really good, because a lot of people have not logged in because of
you can come with
so
the
many
PPT.
reasons.
Probably you can. Our Praveen is a Trissurian. Let him be a member of our esteemed organization.
Yes. Why don't you join us? Yeah.
Yes, I will join. I will come to your office within 2 days or 3 days. Yeah, if it's not open, fine. I will wait for the Diwali vacation to be gone, and I will come and I'm quite happy. The other thing I want to let you know is that I went through the description about us of Architects and Engineers Association, and as I expected, I found very powerful, very innovation-friendly. Description talks about giving engineers their correct importance in society. So this is a very powerful statement. I don't see this in the Los Angeles Engineers Association. I don't see this in the Bay Area. California Association. I don't see this the Dubai Engineers Association. So I'm very impressed. Whoever who wrote that about promoting innovation, about giving engineers their correct position in the society. Shall I speak for 1 more minute?
Yes.
Okay. So I was very impressed, and I also want to add that it is the engineers and the scientists who actually change the world. And whenever I meet animal activists, I tell them that I really support whatever you're saying, but the world's biggest animal activist is the inventor of the automobile, Carl Benz, and his wife, Martha Benz. Martha Benz came from a royal family, and she gave today's $18 million to the smart and bright husband of hers, Carl Benz, and he took about 15 years to create the world's first automobile. Because of this single invention, 90% until the invention of automobile, 90% of the goods transportation on the land was done by the hard labor and the cruel labor of animals. Because of that single invention, 90% of these animals could live in peace. At least they could minus that long, hard labor of walking kilometers a day. And also, Carl Benz's invention of the car is said to create 1 in 6 jobs today. So Carl Benz is also the world's biggest social activist and politician. Of course, Abraham Lincoln is a great man, but it is because of Carl Benz's invention of the automobile. It is because of the pressure of not being able to divide a bus into 2 compartments. You know, before the bus, the trains had 2 compartments for whites and blacks, but you cannot divide a bus into 2 compartments. Because of that, people had to sit along it. Of course, in the initial days of bus, the whites were only allowed to sit, the blacks could not. But you see, many days there are no whites in the bus, so the blacks will sit. It is because of this, I believe bus travel is one of the explosive movement, one of the most powerful moments in history, which actually forced the concept of equality of people. So please do not underestimate. I'm speaking to engineers, and let me tell you that you are all capable of changing the world. You know, engineering is a field in which we all learn in 4 years the most important knowledge of 4,000 years of evolution. And so this is the impression I want to give you. I feel like hugging all of you. It's a great day. It's a great evening. It's a great weather. We are all blessed people to be engineers and also to be in Thrissur. And I will join the AEA, and I want to come and meet you all people. I have many more ideas which can save energy. I couldn't show them today, but in a future time, I'm very happy. I know this is why I'm speaking to schools. I want to make as many people as inventors as possible to save the world.
Thank you. Thank you. Vipin.
Okay, thank you.
Thank you, sir. So I
Thank
hope
you.
we'll call it a day.
Yes.
Yes.
Okay, sir.
We will meet.
With permission of the chair, the meeting is adjourned. Thank you.
Okay.
Thank you all for
Okay.
joining.
Okay, thank you.
Thank you.